So test number 10. Okay, so this it says suppose that your sports car collides into the rear end of an SUV, stopped at a red light. We know that the bumpers lock, brakes are locked, and these cars will skid forward while leaving skid marks on the road before stopping. Okay, so what information does the accident investigator need in order to determine the speed of your sports car before the accident? All right, so this is based upon a problem that we solved before. Obviously, the skid marks need to be measured because of the fact that both vehicles end up locking together and skidding together. The masses of these vehicles are going to be important, so that information needs to be obtained. On top of that, you need to look up the coefficient of friction for static friction. You need to look at the coefficient of friction for kinetic friction, not the static friction, because these things are skidding. All right, so this is more of a question regarding the conclusion of the problem that we solved. Okay, is a martial arts expert that can break 3 bricks stronger than the one that can only break one single brick at a time? Not necessarily. It doesn't need to be stronger, but it's more powerful in a sense. All right, so it doesn't need to be stronger. If it's stronger, obviously it makes sense for him to be able to actually break 3 bricks at a time rather than 1 brick at a time. But both of them could be equally strong. The one that's more powerful is going to be able to break 3 bricks at a time rather than breaking 1 single brick at a time. Okay, so it doesn't need to be stronger, but he needs to be more powerful. More powerful means that he's going to be able to transfer that strength at a larger speed. So you may have 2 martial arts experts who can potentially bench press about exactly the same weight. Assume that that's 300 pounds. Okay, not a pound more. So which means that both of them are going to be equally as strong. The guy who's breaking 3 bricks rather than 1 brick at a time is going to be more powerful because it's going to be able to transfer that force, transfer that strength at a much larger speed, which means that he's going to be moving his hand much faster. So that makes him more powerful, not necessarily stronger. All right, so the next question is, what conserves momentum? What conserves momentum is the absence of an external force on an isolated system. Isolated system is a system of masses interacting with each other. Example of an isolated system, for example, a person getting hit by a car. So the isolated system is going to be composed of a person as well as the car hitting the person. Second example of an isolated system is a train hitting a person or a head-on collision between a car and an SUV. All right, so what conserves momentum is the absence of an external force acting on an isolated system, a system of interacting masses. Under the circumstances, any forces generated during collisions, action and reaction forces, will become internal forces of the system. And there's no external force acting on the system. As a result, the total momentum before and after impact or collision will be the same. So when a person gets hit by a car, momentum is conserved. So when a person gets hit by a car, the momentum is going to be conserved. What about the kinetic energy? Is kinetic energy also conserved? All right, so when a person gets hit by a car, momentum is going to be conserved because it's an isolated system. All right, so this system is composed of a person as well as a car. So any force or forces generated within the system will be the internal forces of a system. So the action and reaction forces will be the same. They will be in opposite directions. How about the kinetic energy, the energy in motion? Kinetic energy is not going to be conserved. Kinetic energy before the impact of collision is not going to be the same as the total kinetic energy after the impact of the collision. Kinetic energy is going to be lost in the form of heat, in the form of sound, in the form of deformation. All right, so no real life collisions will ever conserve kinetic energy. All right, so that's, which means that we're going to be dealing with an inelastic collision. So kinetic energy is not going to be conserved. Every collision is going to conserve momentum, but the kinetic energy is going to get converted to heat. It's going to get converted into sound, and it's going to get converted into deformation. All right, so we got a sharpshooter. He fires a rifle while standing with the butt of the gun against the shoulder. If the forward momentum of a bullet is the same as the backward momentum of the gun, why isn't it as dangerous to be hit by the gun as by the bullet? Okay, so once again, this is conservation of momentum. So the momentum of the gun, momentum of the rifle is going to be the same as the momentum of the bullet. Okay, so both of them will have exactly the same momentum. So momentum is a combination of mass and velocity. So for a given mass, for a given momentum, given constant momentum, larger the mass is, the smaller the velocity is. And smaller the mass is, larger the velocity is. Because the rifle is much more massive than the bullet, the speed of the rifle is going to be much smaller, so it's not going to do as much harm.